Welcome back to Workshop Friend, and this part 3 of reducing rust in my home workshop. In the previous 2 videos I focused on better insulation, starting with the front door, and then in the last video improving the insulation in the ceiling in here, and also cutting down on unnecessary drafts. And I have to say that both those have had a significant impact on the workshop. The temperature in here is much more stable than it once was, so therefore reducing the likelihood of condensation on my machinery, but also it's more comfortable in here. But in this video I'd like to focus more on surface treatments, how I can reduce rust by appropriate coatings. Now in the past I'd been using WD-40, and several of you mentioned that that's not ideal for this task. Some of you suggested ACF 50, which I purchased and have been using since then, and it does indeed seem to be a good product. Now what I'd like to do in this video is test a range of products and see how likely they are to be effective in my workshop. So I've designed a little experiment to put that to the test. Now I should be comparing 7 products, 6 of which are commercially available items. All of them I purchased myself. No company is sponsoring this. This is just my comparison. And one item has been supplied by one of my viewers. So Gordon Tate has kindly allowed me to test a product that he has produced himself with detailed instructions, and we're going to include that in the test. So the items that I'm going to test are, first of all, 3-in-1 oil. Secondly, slideway oil, which I use on my machines anyway. And then thirdly, WD-40, which I have been using. And then this ACF 50, which I've started to use. And then after that, duck oil, which so far I haven't used. Followed by Metal Guard Ultra. And that's another product, a new product to me. And finally, this special product produced by Gordon, which is a plating stroke rust protection solution. So we'll be looking at all 7 products, and I'm going to test them all against a control, which basically is an item with no surface treatment whatsoever. So I produced 8 discs from mild steel. They're each 1 1/4 inch diameter by 1/4 inch thick, and I just quickly parted these off in my lathe. They've all got more or less the same surface finish. The majority of my equipment is cast iron, but I feel it's close enough. So what I'm really doing here is a comparative test, so I hope that's still valid. I've numbered each of the discs 1 to 8, stamped the number on. And so number 1 will be with no coating whatsoever, so that would just be plain machine mild steel. I've not degreased any of these, they just, as they've come off the machine, they've been handled but not degreased. And then number 2, I will apply a layer of 3-in-1 oil. Number 3 will be slideway oil. Number 4 will be WD-40. Number 5 will be ACF 50. Number 6 will be duck oil. Number 7, Shield Tech Metal Guard Ultra. And number 8 will be Gordon's special plating stroke rust protective solution, following his instructions. The way I'm going to conduct the test, originally I was going to spray them, and then I thought actually a better way of doing it would be to simulate actual condensation. So I've got these 2 heavy blocks, and they will both be put in the freezer, and then tomorrow morning we'll take them out of the freezer and put them in their housings like that to slow down the rate of heat loss. So these discs will be placed on top like that, close together but not touching, and then the heat transfer will take place, the discs will cool down, and what will initially happen is we'll get freezing, but after a while condensation will form and we can simulate actual condensation in the workshop. Now I don't know how many times I'm going to have to do this. I've done a trial run with just a plain metal disc, and that was the result from one session. and then on the other side I coated it with oil and repeated it, and there's just a touch of rust forming there. So I think this will work. I don't know, as I say, how many times I'm going to have to do this to test all the products to get a comparison. So it's a bit of trial and error. So what I'm going to do tonight is package up these two blocks and put them in the freezer, and then tomorrow we can start the experiment. Okay, number one, that's without any protection whatsoever. Number two, 3-in-1. Since some of these come in can form, some of them are sprays, I've decided the best way of applying it is to apply them in various ways but finally wipe them. So I've got a similar coating on each and then use a different piece of tissue for each application. Number three is slideway oil. That's much more viscous, so I'm going to have to wipe that to, I think, a similar thickness to the others. I think that's fair. Then number four is WD-40, so this is the first of the spray products. I'll try and spray this away from everything else. Number five is the ACF 50, and this is quite viscous. And then number six is duck oil. This seems to be a lot thinner. And then number seven is the Metal Guard Ultra. And then number eight is Gordon's solution. Now here is Gordon's solution. This is called Tate's number 1, and this version contains molybdenum, and it's painted on. Now I've done some trial runs earlier using it for its other purpose, which is dealing with already rusted equipment. So I had a trial run with it, but here we're applying it as a coating in order to plate the surface, from what I understand. It's all very technical. Now, in its other use, when I was treating rusted equipment, Gordon recommended burnishing the surface. I don't really know if that's necessary with a relatively clean surface like this where there's no existing rust, but I thought I'd try it anyway, and we'll add a little bit more. Now what I'm going to do is let these sit overnight, and then with numbers 2 to 7, I'm going to apply another coat because number 1 doesn't have anything on it. And then on this one, number 8, on Gordon's plated surface, because this, strictly speaking, isn't a rust inhibitor from what I understand, it's more for restoration. So I agreed with Gordon that I would apply a sort of light coat of rust inhibitor, and I'd probably use a 3-in-1 for that. So while these are soaking in overnight, I'm going to take the 2 steel blocks to the freezer, let them cool down overnight, and then we'll come back tomorrow and continue the experiment. Okay, it's the next morning, and the first thing I notice is that the disc number 8, painted with Gordon's solution, has turned this rusty colour, and that is in accordance with his instructions. This needs to be wire brushed now, but the only slight question I have is whether I left this too long. I'm not sure whether it should have been left for a shorter period of time, but we'll continue nevertheless. So I'm going to remove this to one side. Now it says that you can apply water if it's dried out, and this has dried out. I probably should be wearing gloves for this. I'll be washing my hands as soon as I get back inside. Now he says that it's best not to use the tips of the wire brush, but to use a burnishing action. To be honest with you, that's a little easier said than done, but I'm doing my best here. And then it should be vigorously rubbed with the tissue, again following his instructions. Now that surface does look different to me, somehow. Now it says that the surface should be examined for any black or grey areas which signify suboxide and corrosion pits. Well, no surprise, there don't appear to be any here because this has been freshly machined. So this is a slightly different case. But he does say use a rotary wire brush on it. Again, trying to use a burnishing action. Well, I can't see any reason why that needs any further treatment. So I do hope that this is correct, Gordon. But I'm going to follow your instructions now for giving this another plating and then cleaning up again, and then we will put this into the test, and all the items will receive one more coat, and I have yet to decide which coat of oil-based or silicone-based rust inhibitor I'm going to apply to this. So giving this another coating of the solution. And we'll leave that for a while and repeat the process as Gordon explained. I'm going to be removing this out of the way so we don't contaminate it with anything else while it dries. And we'll return to these, and we're going to apply another coat to each of them. So number 2 is 3-in-1. Okay, I've left the plated item for a while and we'll give this a little scrub. Again, I'm trying not to scratch the work as Gordon recommends. I suspect this wire brush is far too coarse, but I'm being careful. Now this time nothing's coming off and there's been no residue like last time. I'll give it a little clean. Okay, I think we'll coat that now with duck oil, and we'll include that in the test. Okay, I think we're ready now to conduct the test, so I'll go and get the cooled blocks and bring them in and place the discs on top. There's no need to rush, there's plenty of heat capacity in these, so we can take our time. They've been in the freezer overnight. Now they are slightly different sizes, different masses, and I just didn't want to waste material unnecessarily, so I think there's about a 25% difference in the mass of them. This looks bigger than it is because it's actually partially hollow at the bottom there, so I weighed them and I think there's about 250 grams difference, about 25%. Yeah, so what we need to do now is place the discs on top. So number 1, number 2, and I'm going to get them as close as possible but without touching, and then number 5, number 7, and number 8. So they'll be cooling down. Initially there'll be some condensation, and the condensation will freeze. Everything will gradually then warm up, and as it warms up there'll be further condensation, and then we can start our corrosion test. Now when I initially planned this, as I mentioned, I was going to spray with water, and I had thought about spraying with saline as well, but it was pointed out to me that might be too aggressive. But I do think this is a fair representation of what was happening in the workshop in terms of cooling and condensation, and I do wonder if there is a difference between spray landing on top of the oil versus cooling happening from underneath and possibly more localized condensation closer to the metal. I don't know if that really is a factor or not, but certainly this is closer to reality than spraying from above. Hopefully that's improved the light. Okay, it's interesting to look at things from a different angle. You can see there the water lying on top, plenty of condensation. So this approach definitely works. Of course I had tried it before, so I knew it did. I tried with 1 coin before, but it works equally well with 4 on each of the pads. Interesting that the pattern of the condensation differs. You can see there number 2 and number 3, they are 3-in-1 and slideway oil. The condensation is kind of separated out, beaded out, whereas number 4, the WD-40, the water is sort of sitting on top and is uniform. I don't know if there's anything to do with the water repellent properties of WD-40 versus ordinary oil. Coming over here, this one at the top, number 5, is ACF50, and that seems to have this kind of waxy texture to it. That's not ice. That's could be emulsified with the water, I don't know, but it seems to have that white sheen to it. Interestingly, as we come over and look at the untreated coin, number 1, you can see that rust is already forming, and that's quite quick. That's just, what, half an hour, 3/4 an hour after the ice melted, and you can see that happening already. So what we're going to do is leave this. It's going to take hours. I'm going to go away and do something else, and we'll come back later. This is at about the 3-hour mark, and you can see that the unprotected disc is continuing to corrode, but so far no signs of rust anywhere else. There are differences in colour, particularly the plated disc here, number 8, but I don't think that's corrosion. I'll come back later and we'll check up in a few hours. And here we have the situation after 3 and 4 cycles of condensation and drying. I was beginning to wonder how long it would take for any of the treated discs to show signs of rusting. This is after 5 cycles of condensation, and at last we're beginning to see this item here, number 2, disc number 2. You can see rust is beginning to show through there. That's the 3-in-1, but so far I can't see any deterioration of the other discs except for the untreated. So we'll continue. It looks like this is going to take several cycles to demonstrate any difference between the other coatings. And here you can see the gradual progress of the corrosion over 7, 8, 9 and 10 cycles. So this is now at the end of the 11th cycle, and this has taken place over about 6 days. The rate of change has definitely slowed down. So I'm going to bring the test to a halt now and try to draw some conclusions. And these conclusions are a little bit tentative and require a little bit of interpretation as well. So the first and obvious conclusion that I've drawn from this test or this experiment is that there's a huge difference between some kind of surface treatment and none whatsoever. And that's evidenced by the fact that it took about 5 cycles before we saw the first deterioration on the treated surface, and that was the 3-in-1 oil. And that's perhaps not a surprise. It was then a long time after that that we saw deterioration here on item number 7, which was treated with the Metal Guard Ultra. And that, I think, was due mainly to contamination. That spot there, a drop of orange juice spattered onto there. I took these samples inside into the kitchen to try and speed up the process of rusting in a warmer environment, and that is where that took place. Now I wiped this away, but still that rust got through. You know, I think really this shows how contamination makes a big difference to the rusting process. After that, Gordon Tate's plated test piece with 1 coat of duck oil. That's beginning to show rusting, more sort of uniform, so that's not due to contamination. Now what's a big surprise to me, and is contrary to what a lot of people said on the comments, is that WD-40 has been very effective, I think, at resisting rust. I can't see any signs of rust whatsoever, and it seems to be in the same league as number 3, which was slideway oil, number 5, which was ACF50, and number 6, which was duck oil. You draw your own conclusions there. Another comment I would make is that these products differ from each other. So ACF 50 is definitely very viscous and thick, and that may be more suited to coating your equipment if you're going to leave it for a period of time, whereas WD-40 and duck oil and the Metal Guard Ultra are all very thin, and they don't take a lot of cleaning if you want to clean them away before you apply regular lubrication. So that's a difference. I think the Metal Guard Ultra is more suited to finer equipment, and maybe my measuring equipment, my calipers, my micrometers, etc., which are going to be stored in a different environment. And I think that kind of coating is much more suited to that, as is perhaps the duck oil, although that's compared very favorably with the other products too. Draw your own conclusions from this, but I'm very surprised by the effectiveness of the WD-40, and I'm also very surprised at how consistent the rest of them are as compared with no treatment whatsoever. What I'm going to do now is just clean the items up quickly and then compare the surface finish after cleaning. So here is how I would summarize the results. Obviously, the most affected is the untreated specimen, number 1, followed by number 2, which was the 3-in-1 light oil. And then I would say number 8, which is Gordon Tate's plating solution with 1 coat of duck oil. And then somewhere between there and the bottom, I would place the Metal Guard Ultra. Now I'm unsure about this because it suffered contamination here, but the rest of it is relatively clean. So perhaps it should be in the highest ranking at the bottom here. So here we have slideway oil, we have WD-40, ACF 50, duck oil, and the Metal Guard Ultra. Interesting to me that these are all pretty much the same, and despite what everybody was saying, WD-40 has come out quite well. Of course, there are many other considerations. I didn't try this on a vertical surface, so whether there is some effect of runoff on vertical surfaces, and some of these coating might be more effective than others, has only been on mild steel, not on cast iron or other surfaces. But I would welcome your comments and your observations as to how I could have made this experiment better, and whether you agree with my results. I'd be interested to know as well. Next video, I'm going to be using Gordon's plating solution for its intended purpose, which is for restoration, and I'm going to try this out on some of my rusted tooling. Thanks for joining me. I do hope you'll join me again next time.